Hey guys, happy Wednesday. So what I want to do today is I want to go back to working with, again, dilations. Specifically today, I want to focus on scale factors, and make sure we have an understanding because I know some of you guys were absent, and I want to make sure I cover it. Um, so you guys know the expectation, right? Make sure you guys follow along. You guys are taking notes. You guys will turn these in. So I would say maybe take notes on the front side, and you'll do the class activity on the back. All right, so let's go ahead and today's objective. So again, students will be able to explain how do you find a scale factor, right? So I want to go back to this because, like I said, some of us weren't here. Now, let's talk a little bit about scale factors, all right? So your scale factor, it tells you again how, whether we're going to enlarge or reduce an image and then by how much, right? That specific number. And the little formula, all we had was new over old, but there's different ways that we can actually represent this. It was your image, right? The new image. And then the other one was the old one, the pre-image. I'm just going to put pre. Okay, you can also have the new one, which is your primes, right? After we do a transformation, we put prime over your original A. So maybe write this down in your notes. Keep it somewhere. This is what you want to go back and refer. So let's work with example number 1 here. All right, so it says figure B is a dilated image of figure A. All right, so again, this is where we have to determine which one was the new one, which one was the old one. So figure B is a dilated image of figure B. So this figure B is going to be the new one. Figure A is going to be your old one. Okay, now let's scoot over here then to the right and label it. So again, our new one is B. So B is the one on the inside here. That's the new one. And then our old one was A. I'm actually going to put new here on the side. All right, and this one was the old one. So just by looking at that, if I'm going from the old one to the new one, was that a reduction or an enlargement? Well, it got smaller, so that's obviously a reduction. So my scale factor should be a number between 0 and 1. Okay, anything bigger than 1, again, that's an enlargement. But all right, how do we find the scale factor? Well, pick a side. For this one, I'm going to choose this top piece right here. Maybe if I use a different color, something like red. This is a distance of 1, 2, 3 units. So the new one measured 3 units. So my scale factor, I'm abbreviated. My new one measured 3 units on the top, and I have to compare it to the same side. So the same side of the old one, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and again, we're comparing the same sides. So the new one was 3, the old one is 9. Okay, so my scale factor is 3 over 9, but I do want to simplify whenever I can. I can actually divide top and bottom by 3. Okay, what's 3 divided by 3? 1. 9 divided by 3 is 3. My scale factor I'll be looking for is 1/3, and that is a reduction. All right, so keep that in mind. All right, let's move on to the next one. Okay. All right, so what I want you guys to do is take a second, see if you can figure this out, and then when you're ready, hit play. All right, so for this one, we have the figure B is a dilated image of figure A. So again, figure B is the new one, A is the old one. All right, so in this case, if I'm going from the old one A to the newer one B, which is bigger, this is of course an enlargement. Right, I got expanded here. So how can I figure this out? Let's go ahead and with the new one, what was the new one here? B. I'm going to count the distance across here. So for the B, the bigger kind of diamond looking shape here. 1, 2, 3, 4, 5, 6. Okay, so it was 6 units across. That was the big one, right? That's the new one, B. Now, what about the old one? Okay, A was just only 1, 2, 3, 4 units. Okay, so it's going to be 6 over 4, but of course we want to simplify that by 2 by 2, and I get 3 halves. Now again, 3 halves, even though it's a fraction, right, 3 halves is greater than 1. So this is, of course, an enlargement. Okay. Now, it would have been difficult, guys. The only reason I didn't go after the sides is because this is diagonal. We can't really count diagonally. It does make it a little bit more difficult in certain situations. So again, I chose to go directly across from one side to the other of this image. Okay. All right, try this one out, guys. Take a second again. See if you can figure out the scale factor. When you're ready, hit play. Okay, so let's run through this. Figure B is a dilated image, so that's the new one. Figure A, that's the old one. Again, make sure you guys always read the directions, right? Sometimes they might accidentally or might switch it on you on purpose to make sure if you're paying attention. Figure B, so here's B, and here is A. Okay, well, it looks like, again, if you're going from A, from the old one here to the new one, it definitely looks bigger, right? So this should be an enlargement. Okay, but now I have to make sure I find the scale factor. Okay, and again, it's the new one over the old one. Well, what's the new one? Pick a side. And again, I try to avoid using those diagonals. That's not really 1, that's not 2. No. It's hard to count that way. So let's go ahead and find a nice straight side. This time I'm going to choose the bottom. So the new one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 units. All right. What about the old one? The old one was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. But of course, I want to simplify that fraction. What can I divide top and bottom by? I can actually simplify by 4. By 4. 16 divided by 4 is 4. 12 divided by 4 is 3. So my scale factor is 4/3. And again, that is bigger than 1. So it makes sense that, hey, this is actually an enlargement. All right. Let's move on to the next one. Again, these are pretty quick, right? All you're doing is really comparing sides, putting the new over the old. All right, so take a second, guys. You know the drill. Try this one. Figure B is a dilated image of figure A. All right, so again, same deal. Figure B is dilated. That's the new one. Okay, A is the old one. All right, so again, if A is the old one here, look at that's a pretty large image. And we're going down to B. That's the new one. Again, this looks like it's going to be a reduction. It's getting shrunken down. Okay. Now again, the scale factor that I figure out here in a second, it better be something between 0 and 1. So my scale factor, let's go ahead and find the new over the old. So what's the new one? The new one is B. I'm gonna go after the bottom side here. It looks like the straightest one, easiest to count. 1, 2, 3, 4. Okay, that was a distance of 4 units. What about the old one? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 4/8. If I actually simplify that, divide the top by 4, divide the bottom by 4, I get 1/2. So my scale factor is 1/2. And again, it makes sense, right? Less than 1, that is going to be a reduction. So we actually see that image becoming much smaller. Okay, I got a few more for you guys to practice. And again, this is going to be a very, very short unit. You guys will probably be taking your test sometime next week. And I want to make sure we just get the practice in since I'm not there. All right, figure B is a dilated image of figure A. Find the scale factor. All right, so try it one more time. Now, this is going to be a little awkward, right? You got some diagonals. Try not to count. Find a nice straight side if you can. Okay, when you're ready, hit play. Okay. So for this one, figure B is a dilated image. So again, that is the new one. Figure A is the old one. Read the directions, read the directions. Okay. Now, it's kind of weird, right? And actually, now that I see the image, right, it's like, whoa, 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 whoa. Well, B, if B is the new one, it should be the one that has the primes, right? So the blue one here, notice prime, prime, prime. This is going to be the new one. Okay. The red one inside was the old one. I should use different letters there. But okay, that's fine. Our scale factor, this is why I make sure it is new over old, or we can say our prime over our old standard A's. Okay, so let me look at the blue one because that's the new one. That's a diagonal. I'm not going to do that. That's a diagonal. I'm not going to do that. So I'm going to count this right side here. So 1, 2, 3, 4, 5, 6, 8, 9, 10. Okay, That's a distance of 10. I better compare it to the same side over here of the old one. So the original A, B, and C. So 1, 1, 2, 3, 4, 5. Okay, that's 5. Well, 10 divided by 5, that's easy. That's just 2. Okay, and again, it's 2. 2 is bigger than 1. So if my scale factor is 2, okay, this should be in a large, and it makes sense, right? You went from the red to the blue. It got blown up by a scale factor of 2, so it makes sense that it actually grew. Okay. Example 6. Find the scale factor for the dilation. The preimage is W. Okay, so again, the preimage, keyword there, is W. And the image is X. All right, take a second, see if you guys can find the scale factor. All right, so if the preimage is W, that means pre means before, so that's the old one. Okay, the image, right, is going to be the new one. So my scale factor, new over old. All right, let's go after the new one first. That's X, which is the little one down here. Okay, so if that's the new one, right, that means that it is a reduction. So again, I should be thinking right now, hey, a number between 0 and 1. Okay, now I just got to pick a side, pick a nice side. And you have plenty to choose from. I'm just going to pick the bottom. So 1, 2, 3, 4, 5, 6. Oh, I was already counting. Duh. So it's okay. So that one's 6, and I got to compare it to the old one, which was the pre-image down here. All right, I'm assuming they counted correctly. That's a distance of 18. Okay. Now, please simplify all of your scale factors. I can simplify this one by 6 and by 6, and I get 1/3. And again, it makes sense. It's a fraction between 0 and 1, 1/3. So if you go from your pre-image W to your smaller image X, it got shrunken down. All right, it got reduced. All right, last one here. Okay, you work at a photography store. A customer has a picture that is 4.5 inches tall. We see that right here, 4.5 inches tall. Okay, the customer wants a reduced copy of the picture to fit on a space of 0.9 inches tall on a postcard. Okay, so we want to make sure that picture is able to fit in here so they can send it on a postcard. Okay, what scale factor should be used to reduce the picture to the correct size, right? You got to figure it out, or else you're going to make it too small or too large and it's not going to fit in that rectangular box. Okay, so our scale factor should be new over the old. Okay, well, which one's the new one? Well, the new one is the one that I want here. It's the 0.9. What was the old one? Well, the old image measured 4.5 inches. Okay, well, if I divide that, let me use a calculator real quick. I want to say it's like 0.2.9 divided by 4.5. Whoa, what did I do? 0.9 divided by 4.5. It is going to be 0.2. That is going to be our scale factor. And again, this time, right, I wrote it as a decimal, but we noticed that 0.2 is between 0 and 1. So it makes sense that, hey, this is a reduction. I know I'm on the right ballpark. We shrunk that picture down to fit. All right, guys, here you have it. You have 4 problems. You are finding the scale factors for problem number 1, problem number 2, problem number 3, and problem number 4. All right, guys, when you are finished, go check your answers with my sub. They have the answers. If everything's perfect, I do want you guys to turn in both your notes and your class activity together. So again, if your notes covered up one side, flip over to the back, finish these last 4 problems on the back side. All right. So other than that, guys, I will see you guys soon. Have a great day.